Okay, welcome to Level 1 Science Online with Henny van Vieren.
Hi guys, welcome to our first online lesson for the first lockdown, hopefully the last lockdown in 2021. Yesterday we finished off by looking at compounds and molecular formula, and today we will take that a little bit further. So without further ado, let's press on. Beautiful. Okay, so we're talking about compounds. Remember when two um, so when two molecules come together, or two atoms come together, or more than one atom come together for that matter, um, we form a compound. And compounds are frequently more stable than the original ones, but they are bonded together. Okay, so we have ionic and covalent, and we're going to be looking at ionic compounds because we looked at atoms and ions, didn't we? So we want to see what happens when two ions come together. So ionic bonding is when, for instance, the metal atom, and that's everything on the left hand side of the red line on the periodic table, combined with a non-metal. Okay, so for instance, hydrogen wants to give its one electron, and chlorine wants to take a negative electron, and then you have hydrochloric acid. This forms a positive ion, which is a cation, and an anion, which is a negative ion. And the electron is transferred between the two, and that's how the bond happens. Okay, we looked at all of these. We looked at this excellence question, and we saw that when aluminium and for instance, aluminium is 3 plus, okay, so it wants to give away 3 electrons. Sulfide is 2 minus. Now negative will attract positive, so these two can combine, and chlorine is negative as well. Negative will attract positive, so they cannot combine. But sulfur and chlorine will never combine because similar charges repel each other. Okay, for chlorine or for sulfur to give away, chlorine has to give away 7 before it can um, play the role as the positive one, and that's never going to happen. It will always accept an electron, and this will always accept 2 electrons. That 16 plus that you see there in the middle simply refers to the 16 protons, and it's balanced out by the 16 electrons in the atomic state. In the ionic state, you will have more or less protons than electrons, depending on if it's going to become negative. So sulfur ion will accept 2 extra electrons, therefore you have 2 more electrons than negative electrons than positive protons. So the net charge is minus 2. Okay, we looked at that. Alrighty, so then we talked about a simple formula like this. So H2O. How many H's? There's 2 of them. How many O's? There's 1 of them, and they are in a compound. Okay, so quite easily with that one. But when you have it like this, it is much more complicated. But the good thing is it's quite simple because it's always the same. So we have 2 magnesiums, 2 magnesium nitrate molecules. The number that's in front always referred to the whole molecule. So there's 2 of these molecules. Magnesium. In a single molecule, there's only 1 magnesium because there's nothing down here. Let me just get my laser pointer. So there's nothing down here. And because there's nothing down here, there's only 1 of them per molecule. But because there's 2 molecules, you take this 2 and it multiplies with that one, and that's why you have the 2 over there. Now, we have a bracket and a bracket and then a 2. What they do is when it's a, remember we talked about a polyatomic ion, poly meaning more than 1, atom, polyatomic, more than 1 atom. So in this case, there's 1 nitrogen and 3 oxygens, that's a nitrate. But there's 2 of these nitrates, so 2 nitrogens combined with 3 oxygens, that then bind with 1 magnesium. So this 2 refers to everything in the brackets. This 3 only refers to the atom right before it. So in this case there's 3 oxygens multiplied by the 2 over here gives us 6. Multiplied again by the 2 in front over here, that gives us 12. 2 multiplied by the 1 nitrogen gives us 2 multiplied by the 2 in front, which gives us 4. Okay, and we'll do a few examples of that in this iPad. I imagine quite a few of you didn't get your iPads from school, so I'll upload the right pages for you so that you can do them. Okay, so how do we know how to write? So when aluminium, for instance, reacts with oxygen, okay, so the aluminium, we know aluminium wants to give away 3, and you find, oh my goodness, and you find that right in your, you find that exactly in your table of ions. And remember, this table of ions was given to you, so you know that aluminium wants to give away 3. Oxygen, on the other hand, it wants to accept 2. Now if aluminium wants to give away 3, it means that it is in group 13, and if oxygen wants to if oxygen wants to accept 2 electrons, it means that to get to 8, so it has to at that stage have 6, and that puts them in group 16. Hope everybody still understands that. Okay, so that's where that 3 plus comes from, and the 2 minus. But how do you get these two to go together? Okay, so there's a 3 plus and a 2 minus, and I told you that they need to balance out. And if you just put these two together, it's going to give you plus 1. That's not going to work. So a little bit of maths, okay, and we go to, I think it's called the lowest common denominator. So the smallest number that both 2 and 3 can divide into, and in this case it is 6. So how many oxygen 2 minuses, so 2, how many 2's go into 6? Here we go. So how many 2's go into 6? And that needs to be a negative charge over there. That is 3 of them. Okay, let me just fix that. This needs to be a negative charge, okay? So 2, how many 2's go into 6? 3. How many 3's go into 6? That is 2. Okay, so that means if we take 2 aluminiums, it's going to give us a charge of 6 plus. And if we take 3 oxygens, which is 2 minus, so 3 of them is 2 minus, 4 minus, 6 minus, and that balances out nicely. And then we have a balanced and stable molecule. Okay, so you all understand. So you take the common denominator between the charges, so a 3 and a 2, the common denominator is going to be 6. Then you find how many needs to go in there, and that becomes the number at the bottom. 2 and this one would be 2. That goes down here. So 2 aluminiums give me a charge of 6 plus. 3 oxygens gives me a charge of 6 minus, and they cancel each other out. Let's look at that visually. Okay, so copper is 2 plus. Okay, so it loses 2 electrons. Now if you think about it, let's pretend that was full and it wanted to give that block away, and it wants to give it to chlorine. So it means that 1 chlorine can bind on there, because chlorine is only 1 minus. Therefore we need 2 chlorines to come and take copper's 2 electrons. And that is why it ends up to, as copper chloride is going to be CuCl2. Cu and 2 Cl's. Can you all see that? And we can visualize all of them in that same way. So if we wanted to take, for instance, magnesium, and oxygen, 2 spaces and 2 that want to go into there. Okay, so that is a 1-to-1 ratio. But if we want to make water, we need 1 hydrogen to click on that one and 1 hydrogen to click on that one. So that is H2O. Alright, so sodium is going to be 1 onto sodium and 1 onto another sodium. And hence it will be sodium sulfate. Okay, so when we're working with charges of 3 plus and 2 plus and so forth, let me just change my ink color here. We said earlier that we're looking for the common denominator, okay, and in other words the smallest number that both the 3 and the 2 will both divide into. In this case that's a 6. So we're looking for a charge of 6. Something that's going to create a negative charge of 6, something that's going to create a positive charge of 6. And to create a positive charge of 6, we need 2 aluminiums. Okay, so there's 1 and 2. Okay, so now we have, on this side, we have positive 6. And then on this side, we need a negative 6. And for that we take minus 2 and another minus 2 and another minus 2, and that gives us a negative 6. So how does this work? You have aluminium 3 plus, which means I can accept 1, 2, 3 electrons. Then you have another aluminium 3 plus. So now it can accept a total of 1, 2, it wants to give away, sorry, 1, 2, 3, 4, 5, 6 electrons. And oxygen now, look how many it can accept. 1, 2, 3, 4, 5, 6. Whee! I hope you like my animation. I'm going to work for DreamWorks one day. Maybe not. Okay, so then on this side we have positive 6, and on this side we have negative 6. Another way that other people do it, I know the chemists don't even want us to teach you this, but it is a much quicker way when you are working with things of charges. So if you have aluminium 3 plus, so the cation and the anion, and oxygen 2 minus, you cross and drop. We call it swap and drop. So the 2 goes from there, it swaps across to aluminium and drops down aluminium 2 plus. Aluminium, oh, not aluminium 2 plus, 2 molecules of aluminium is going to give us plus 6. Do you agree? On this side we go swap 3 and down, swap and drop. So it becomes oxygen 3. So 3 times minus 2 gives us minus 6, 2 times plus 3 gives us plus 6, and then you have a positive 6 and a negative 6. So that's a much faster way of doing it. Here's another example. You have hydrogen 1 plus and sulfide 2 minus. Swap and drop, so 2 goes to hydrogen and 1 goes to sulfide. But remember, we don't write that 1, so we don't need the brackets. So that becomes H2SO4. Does that make sense? So swap and drop. We'll do some more examples of that soon. Okay, so I think that's what we're going to call it a day, and I'll give you some exercises to do just to make sure that you guys are all good with this. Alrighty, I hope you have a great day, and I will speak to you again soon. Bye.